This lecture will be of multiple episodes. I'm making the videos of episode number 1, 2, and 3, and then 4. It's like 45-minute lecture, and then the video will over. And after that, next video. So yeah, I was telling you, denary number, decimal number is the same thing. And we got the digit 0 to 9. That is why the base is 10. In binary, there are two-digit base is 2. And in hexa, 0 to 9 altogether are 10 digits. And there are 6 characters. So 10 plus 6 becomes 16. That is why the base is 16. Decimal number system is for the human. We deposit money, withdraw money, we give money to someone, someone is paying back or returning you your money. So we deal in decimal number system and denary number system in our routine life. Then binary is for who. So number like 1, 0, 1, 1. If you have a number combination like this one, so that's called a binary number. So in binary, we use zeros and one combination, and computer is always happy to see this. Computer have no difficulty in converting or understanding these binaries, and computer would convert all type of data into binary, whether you talk about text, you talk about numbers, you talk about symbols, you talk about images, sound, videos, all kind of data is converted into zeros and one, and then the data can be processed by the computer system. So this kind of data, the binary combination is to be used by the computer. Then comes the uses of hexadecimal numbers. Hexadecimal use number 1 is it is used to change the color for the color codes that you use while developing website. Color codes in websites will always be in this format of hexa. That is the use number 1. And use number 2 is for the memory dumps, meaning the memory addresses that are given in binary form like that. It's given in hexa form. Then third use can be used for the MAC addresses. Fourth use can be used for IP addresses. IPv not 4, IPv6. I'll take you in the details of that in a while. So it can be used for IPv6. Now, use number 1, that we say that all the developer website designers, they prefer to use hexa code while developing web pages, while writing HTML program. Well, if you want to see the practical example of that, how would you see that? You can come back here, you can go onto Google, and then you can write there W3 web colors schools colors code HTML. You can write that W3 school color code HTML. It will take you to the website. And where you see this link HTML color picker, you can click there. And you see this full library of color there. You can click on the color. Now you have chosen blue, and it is showing you this blue here. And with this blue, there are many other shades also. And for every single shade, you can see the color code in hexa is written on the right-hand side. Similarly, if you select any other color, for example, the pink or the blue or whichever color you select, all the combination would come up there, right? So you can pick the color, and it shows you all possible combination and color shades. This was the use number 1. And we see that here. All these codes are all hexa codes for every single shade. You see a different color. And for this pink color, you see this one here. The color code is there. So all these color codes are given in hexa form, right? Now moving to the next example, memory dumps. Memory dump was something that we had in assembly language. We used to give this command. We can't do that now. I cannot do it here on my PC. You can try that on a very old PC of Pentium 1 type. If any of you have it, you can turn it on. And you can go to the command prompt. This kind of window will appear. And over there, write debug. When you write debug, it will take you to a program that shows you a cursor. I'll show you what kind of a screen would appear after that. This kind of a screen would appear, just this thing. And then you can write dump. When you write dump, it shows you memory location and the data stored in it. One definition of the memory that we have studied before is that memory is a collection of addressable bytes. Every single memory location has an address. For example, if I say that's the memory location, for example, these are the memory locations, right? And we see boxes in it, meaning these are individual bytes. Every single byte can be addressed using a different hexa code, right? FF01 and then FF02 like that, and then FF03 like that. So this particular location, that's an address. At this address, what do you have? These are the content. So when we do memory dumps, so it shows you address as well as the content, and this content will also be written in hexa form. Like 41 is written there. So that means 41 is written at location of FF01, but don't think that 41 is a value. 41 can be the code of a letter. Just in my, I think, of introductory session, I think we talked about ASCII code or not. So I'll just tell you, A is equivalent to 65. The code of capital A is 65. When you convert the 65 into hexa, we can try that here, dec to hex directly. We get 41. So actually that's the code of A in hexa language. So this is how memory dumps can be checked, can show you the memory contents and the addresses. And we can try that here. You can write memory dumps in assembly language. I can try images so that you can see what pictures would appear there. Just memory dumps. Yeah, like this one. So that's the use number 2. The hexa used for memory dumps. Look at this. It says dump 2000 to 2200. That means it starts showing the memory from this address to this address. And that you see here, that is location number 2000. On the right hand side, that's the data stored here. Every single thing that you see here, that means these are the bytes. This byte number 1 has this data at the rate, byte number 2 is blank, 3 is blank, 4th is blank, and then later on you see more data there. So it is showing you a picture of every single byte. On the left hand side, you have addresses. On the right hand side, you have the data. So this is how the memory dumps can be seen. The next example, this meeting will over in 10 minutes and you can rejoin, right? Like I said earlier. The next is MAC address. And trust me, the best example of the MAC address, the best explanation that I found in any book up till now is always that O-levels book. Even in A-level book, MAC address is not given in that detail. You have studied that MAC address is a combination of 2 sets. Each set will have another 3 sets, altogether 6 sets. And MAC is a physical address of a LAN card. So we say that, yeah, there are 2 sets in it. In MAC, which is media access control MAC address, there is set number 1 and then set number 2, a set of N and then set of D. Set of N contains another 3 sets, pair, 1 pair, 2 pair, 3 pair, 3 sets. And then there are subsets in D's also. There are set number 1, set number 2, set number 3. This set of N tells you make. And then set of D's tells you the serial number. You bought the new laptop, for example, and you bought the laptop of IBM or maybe Dell or maybe Compaq. So those are called makes. So every company is identified using their own unique number, code. And when that computer is made by an industry, they always put the serial number on it. They always paste the serial number at the back of the laptop. And you can turn your laptop and you can see the serial number. Why that serial number is mentioned on it? So that just in case if hardware malfunction would come up, problem would come up, and it covers the warranty also, you can take it back to the vendor and you can say that the laptop isn't functioning, it's a new laptop, you can give it back. They always refer to the serial number to keep a track whether, yeah, you are returning the same laptop. Was it made by that industry, factory, that particular make or not? So this is for the verification and make that what computer you are using. So these two in combination gives information about the user computer that you are using, Dell computer, Compaq computer, what is the serial number. So IP address is another thing that we have in network, a number like this, the combination of 4 number 196, 192. In Karachi, Pakistan, we have this kind of number for PTCL, suppose. So these three tells you the organization. The last one is the server number 0. So that means PTCL organization. Where is it? It's in Pakistan. So one can, anywhere in the world, they can recognize it easily that this number or the first 3 digits tell the organization. They can find that organization easily. Yeah, PTCL is located in Pakistan. And then PTCL, what server is used? 0 server. So when you are connected to the internet using your phone or laptop or whatever device, your IP address will always be used. It's supplied to the other server machine. It's given to the network. Using this IP address, your position can be tracked. Where are you located? That can be found. And then after that, if I want to find that what kind of computer you are using, so when you pass on data from your computer system, so 2 things are sent. IP address is sent, and with that, this MAC address is also sent. So if you are a hacker, for example, so hacking can put you in trouble now, because using IP address, people can locate your position, and using this MAC address, they can find physically, they can come to your place and they can raid and they can check whether the person who hacked the system was using the same computer that you have. If you are caught, that means you can be in trouble in that case. So MAC and IP in combination, both can be used to find out details about the hacker, right? So it says that every MAC address first set can have different number, and that tells you the different make. So if you have this number, that means you're talking about Dell computer. You got this number, that means you have Cisco. You have this computer, that means you have Intel. And then the rest of the number tells you about the serial number. The rest of the numbers are the series of N is the serial number, right? So there are 2 numbers. N is about manufacturers. N tells you the manufacturer, and D tells you the serial number. So I hope you understood. And now we have 5 minutes, and in 5 minutes I won't be able to cover up IPv6 and IPv4. The discussion can go long for about 15-20 minutes. I want that to be recorded separately in a different video. We can end this first episode here, and you can come back quickly. I'll end it and I'll rejoin, and you can also rejoin. Come back quickly.